Right now, 95% of the smartest, most well-funded companies on Earth are getting exactly zero return on their investment in artificial intelligence.
Yeah, zero. It's actually kind of staggering.
It is. I mean, a massive, comprehensive MIT study just came out and confirmed this.
Right.
The vast majority of these corporations are pouring billions into generative AI, and it's not moving the needle on their bottom line one single inch.
Not an inch.
But then, if you open any news app or listen to literally any tech CEO or just scroll through LinkedIn for 5 seconds, you are being screamed at that AI is the most transformative invention since fire.
It's the ultimate paradox of our current moment, really.
Exactly. So, welcome to the deep dive. Our mission today is to cut through this absolute extreme noise.
Because there is so much noise out there right now.
Way too much. We're going to look past the breathless hype, and we're going to look past the doomsday panic, too.
We have to. Resolving that contradiction is really the only way to figure out what happens next.
And that is exactly what we are doing today. We are going to answer the ultimate question sitting on the mind of every single person listening to this right now.
Which is, how do you actually survive this?
Right. What is the single most important skill you need to survive and actively thrive as AI completely reshapes the workforce?
It's the billion-dollar question.
It totally is. And to do that, we're pulling from a stack of incredible source material today.
Yeah, we're unpacking a really in-depth interview with an economist of technology.
Right. Someone who has been studying the economics of technological change for, what, a quarter of a century?
A full 25 years, yeah.
Mhm.
This is the co-author of seminal books on the topic, specifically Prediction Machines and Power and Prediction.
So we are bringing you the historical structural perspective today.
Exactly. Because when you have 25 years of studying how technology impacts global economies, you tend to ignore the daily Twitter drama.
Oh, totally.
You look for the underlying structural shifts instead.
Because whether you are a brand new college grad sending out your first wave of resumes, or, a mid-career marketer trying to secure a promotion.
Or a seasoned corporate lawyer billing hundreds of dollars an hour.
Exactly. The stakes could not be higher for you. The skills that gave you dominance before AI are simply not the skills that will give you dominance after AI.
The rules of the knowledge economy are actively being rewritten, like right while we are all out on the field playing the game.
Which brings us back to that staggering MIT statistic. The 95% of companies getting zero ROI.
Right.
If this technology is truly as powerful as everyone claims, and our sources firmly believe it is, how is it mathematically possible that 95% of these corporations can't squeeze a single dollar of profit out of it?
It feels like we're being sold a bill of goods, doesn't it?
It really does. The math just isn't mathing.
Well, to understand why the math isn't mathing today, we actually have to look backwards.
Okay, let's unpack this.
This exact disconnect, a period of massive technological hype, followed by a seemingly total lack of immediate economic results. It's not a glitch in the matrix.
It's happened before.
Oh, absolutely.
Yeah.
It is a deeply entrenched, well-documented historical pattern. Economists actually have a specific technical term for this period.
What's the term?
It's called the co-invention lag.
The co-invention lag. Okay, I want to spend some serious time here.
We should, because it's crucial.
It really feels like the skeleton key to understanding the entire AI landscape right now.
It totally is.
If I am an executive or just an employee trying to champion a new AI tool, and my boss asks where the ROI is, I need to understand this lag.
The best way to visualize the co-invention lag is to travel back to the late 19th and early 20th centuries.
Okay, setting the scene.
We need to look at the commercialization of electricity. Today, we view electricity as the foundational technology of the modern world, right?
Yeah, without it, global civilization halts instantly.
Exactly. But the historical reality of its adoption is actually shocking.
How so?
20 years after the invention of the electric light bulb and the electric motor, only about 3% of manufacturing companies had actually adopted it.
Wait, really? 20 years?
2 full decades, yeah.
Wow. We feel like we are drowning in AI fatigue, and ChatGPT has only been mainstream for a few years.
Right, and it took 20 years for electricity to hit a measly 3% market penetration.
That is wild.
And it gets worse. That early 3% of adopters, they saw almost zero economic benefit.
So they were experiencing the exact same zero ROI phenomenon that modern companies are experiencing with AI today.
Precisely. To understand why, you have to look at the physical reality of a pre-electricity factory floor.
Let's do that, because I think our modern brains just imagine a 19th century factory as, like, our current factories, just a bit dirtier and maybe with more sepia tones.
Right, like an old photograph.
Yeah.
But structurally, they were fundamentally different machines. Entirely different.
How do they actually work?
Well, a pre-electricity factory obviously didn't get its power from invisible wires hidden in the walls. The power source was massive, localized, and singular.
Like a giant steam engine.
Exactly. You had one giant steam engine or maybe a massive water wheel situated physically on the outside of the building.
Okay, so you have one massive engine on the exterior.
Right.
How does the power actually get to the worker cutting the wood or weaving the textile on the complete opposite side of the building?
Through a frankly terrifying piece of engineering called a line shaft.
A line shaft.
Yeah, that exterior C engine turned a single, incredibly long, wildly heavy steel drive shaft that ran the entire length of the inside of the factory.
Just suspended from the ceiling.
Usually, yes. And on that massive spinning pole of solid steel, you had a series of wheels.
Okay, I'm picturing it.
Attached to those wheels were these thick leather belts that dropped down to the factory floor to physically power every individual lathe, loom, or saw.
Wow, the friction alone on a system like that must have been astronomical.
Oh, it was. The energy loss was staggering. You're turning tons of steel just to power one machine sometimes.
That seems so inefficient.
It was. But more importantly for our discussion of economics, that power system dictated the entire physical architecture of the business.
Because you couldn't just put machines wherever you wanted.
Exactly. You could not just build a factory however you wanted. That steel line shaft was so unfathomably heavy that it required massive, thick timber collars spaced out every 10 feet just to support the weight.
Which means your factory floor is essentially a dense forest of wooden pillars.
Right in the middle of your workspace.
So you can't easily move materials around.
Not at all. Furthermore, a single steel shaft can only be built so long before the sheer weight and friction make it impossible for the steam engine to turn it.
Ah, so you hit a physical limit on the size of the building.
Precisely. You couldn't build long, sprawling, single-story factories. If you wanted to expand your business, you had to build up.
Multi-story buildings.
Yes, you had to stack your factory floors on top of each other, these multi-story brick buildings, so that all the machines could stay within a few dozen feet of that central vertical power shaft.
The physical limitations of the technology literally trapped the business model inside a specific architectural box.
That is the perfect way to phrase it. Which brings us to the moment of technological disruption.
Okay, the electricity salesman arrives.
Right. A salesman walks into one of these multi-story, pillar-filled factories and says, I have this incredible new technology called electricity. You need to adopt it.
And what does the factory owner do?
The owner, looking to reduce operational costs, says, okay, I will replace my gas lamps with electric bulbs, and I'll rip out my coal-fired steam engine and attach one giant electric motor to my central steel line shaft.
Wait, so they didn't change the factory at all?
Not structurally, they just swapped the power source.
They took the new technology and aggressively crammed it into the exact same legacy workflow.
And the result was negligible. Taking an electric motor and using it to turn the same heavy, friction-filled steel shaft in the same multi-story building.
It just shaved, what, maybe 1 to 2% off their operational costs?
Exactly. That is it, a 1% gain.
A 1% gain is a rounding error. No rational business owner is going to halt production, risk their supply chain, and spend massive amounts of capital retrofitting their factory for a 1% efficiency gain.
So the narrative became, electricity is overhyped.
Wow.
People literally said it doesn't actually move the needle. Yeah. The juice is not worth the squeeze.
So the early adopters got zero ROI because they treated electricity as a simple substitution.
Yes, they didn't change the underlying process.
This maps flawlessly onto that 95% MIT statistic.
It really does.
We are seeing companies buy these expensive enterprise AI licenses, and all they're doing is using it to slightly speed up the exact same bloated workflows they've been running for 20 years.
Right. They're using an LLM to draft the same unnecessary corporate memos 10 minutes faster.
Or they're summarizing the same useless hour-long meeting.
Exactly. They're putting an electric motor on the old steam shaft.
So when did the actual boom happen for electricity?
The real economic explosion. The 300 to 500% productivity lift that birthed the modern industrial age. That didn't happen until a new generation of entrepreneurs realized what the technology actually enabled.
What did they figure out?
They realized they did not need the central line shaft at all. Because electricity travels through wires, they could put a tiny fractional horsepower electric motor on every single individual machine.
Oh, wow. Which changes the entire architecture.
Completely.
Hmm.
If you don't have the heavy steel shaft, you don't need the massive timber support columns blocking your factory floor.
And if you don't need the machines clustered tightly around a central shaft, you don't have to build expensive multi-story brick buildings in the middle of a crowded city.
Exactly. You can move out to the suburbs where land is dirt cheap. You can build a massive single-story warehouse with a clear span roof.
And once you have an open floor plan on a single level, you can finally optimize the flow of the actual work.
Yes, you arrange the machines based on the logical sequence of production, not the arbitrary distance to a power source.
And the modern assembly line is born.
And productivity skyrockets by 500%. The companies that stuck with the steam engine and the line shaft simply could not compete, and they evaporated.
But that process, the realization that the factory floor needed to be redesigned from scratch, the tearing down of the old buildings, the invention of the unit drive motor system, that is the co-invention.
You've got it. The underlying technology is basically useless until human beings co-invent the new business models and workflows required to harness it.
And co-invention is highly complex, incredibly expensive, and takes a very long time.
Exactly.
But if we follow this logic through to its conclusion, it paints a rather grim picture for existing corporations.
How so?
Well, the true winners of the electricity era were the entrepreneurs who built the new single-story factories from the ground up. The legacy companies died.
That's historically accurate, yes.
And when the internet arrived, the winners were largely internet-first companies like Amazon or Google who built digital native workflows from scratch.
While legacy retailers like Sears or Blockbuster, who just tried to bolt a website onto an old catalog business, were wiped out.
Right. Doesn't this mean every existing incumbent company today trying to slot in AI is basically doomed?
It's a valid fear.
Are we just waiting for a couple of kids in a garage to build an AI-first enterprise from scratch and destroy the current Fortune 500?
That is the trillion-dollar anxiety keeping every legacy CEO awake at night right now.
The innovator's dilemma.
Exactly. The innovator's dilemma suggests that incumbents are almost always too slow, too tied to their existing profit margins to survive a true paradigm shift.
So they are doomed.
Actually, no. Our source, drawing on deep economic theory, argues that AI represents a massive break from historical precedent.
Really?
Yes. In the AI era, incumbent companies actually hold a potentially insurmountable advantage.
Okay, I am going to need you to defend that.
I will.
Why would an old, slow legacy bank or healthcare provider have an advantage over a nimble AI-native startup with zero technical debt?
It comes down to the fundamental nature of the technology itself. AI is the very first tool in human history that natively, fundamentally learns from use.
Okay, explain that difference.
Think about a traditional software program, say a relational database or a word processor. It does not get smarter the more you use it.
Right, Microsoft Word doesn't learn how I write and suddenly invent new features for me.
Exactly. It executes the code exactly as written, forever. So a startup can build a better piece of software in a garage and instantly have a superior product.
But AI is different.
Fundamentally different. A large language model, or any machine learning system, requires a continuous feedback loop to improve its utility in specific domains.
And who has the most robust feedback loops?
Exactly. The companies with the largest existing user bases.
Oh, wow. I see where this is going.
Let's look at a legacy enterprise software company with 50 million daily active users. If they deploy a clunky first-generation AI tool into their workflow, it might not generate immediate financial ROI.
The 95% with zero ROI.
Right. But what it does generate is 50 million daily data points of human interaction.
Every single day.
Every time a user accepts an AI suggestion, rejects it, edits the output, or asks a follow-up question, that interaction data is captured.
And the incumbent uses that proprietary domain-specific data to fine-tune and align their models.
Yes. So the legacy company is essentially building a massive data moat.
While a startup in the garage, what do they have?
The startup might have access to the exact same foundational model from OpenAI or Anthropic, but they have zero customers.
They have no real-world edge case data.
None. They can't train the model on the specific nuances of how a procurement officer actually negotiates a contract or how a nurse actually charts a patient's symptoms.
Because they don't have the nurses or the procurement officers using their platform.
Exactly. The incumbent's AI gets smarter every single day, uniquely tailored to their exact business use case,
Yeah.
driven by the sheer volume of their existing customer base.
This means that if you are an executive or a manager at an incumbent organization right now, looking at that MIT study and deciding to hit pause on AI because the ROI isn't there yet,
You are making a fatal error.
you are giving up the one structural advantage you have.
Every day you sit on the sidelines waiting for the technology to mature, your competitors are deploying it.
They're gathering interaction data.
And they are generating the feedback loops that will eventually power their single-story factory workflows.
So the cost of inaction is exponentially higher than the cost of a failed pilot program.
Exponentially higher.
But this creates a massive tension in the broader market, doesn't it?
How do you mean?
Well, if AI is this inevitable structural necessity and everyone has to invest in it just to survive, why is there such a palpable rising panic that the entire AI industry is a massive financial bubble waiting to pop?
Yes. The bubble anxiety.
You can't read the financial news without someone predicting a massive crash.
And honestly, the anxiety is completely justified when you look at the macroeconomic landscape.
Right.
We are currently witnessing a concentration of capital that borders on the absurd.
Give me the numbers.
Roughly 30% of the entire market capitalization of the U.S. stock market is tied up in just 7 companies.
The so-called Magnificent Seven.
Yes. Apple, Microsoft, Alphabet, Amazon, NVIDIA, Meta, and Tesla.
30% of the entire market. That is a staggering amount of wealth resting on a very small foundation.
It's unprecedented.
And what are those companies actually doing with all that capital?
They are pouring hundreds of billions of dollars into capital expenditure, primarily building massive data centers across the globe.
They are buying up land, securing gigawatts of power from the grid, and packing these warehouses with millions of hyper-expensive GPUs.
They are making an astronomical, historic bet
A bet on what?
that there will be nearly infinite future demand for both training next-generation foundational models and for inference.
Inference, meaning the actual computational power required every time a user prompts an AI?
Exactly. They are building the infrastructure before the actual consumer demand is fully materialized.
They're assuming we will all be using AI agents 1,000 times a day, and they are building the server capacity for that future right now.
Yes.
That sounds incredibly precarious.
It is. And our source uses another brilliant historical framework to explain this risk. He maps the current massive investment in data centers directly onto the massive investment in railroads during the 19th century.
Let's explore that railroad analogy.
It's a great one.
Because on the surface, railroads are the ultimate success story. They connected the country, created national markets, birthed the modern corporate structure.
In the long term, yes.
Right.
The railroads were wildly successful and completely transformed human geography.
But in the short term,
The financial history of railroads is a story of catastrophic bubbles and devastating crashes.
Yeah.
Oh, absolutely. The investors who funded the initial wave of railroad construction built the tracks way, way out ahead of the actual economic use cases.
they were laying thousands of miles of heavy steel track through the wilderness, connecting point A to point B.
And then looking around and realizing there were no actual towns at point B yet.
Wow. So the infrastructure was laid, but the co-invention lag had just begun.
Exactly. It took decades for society to actually organize itself around the rail network.
I guess farmers had to shift from local crops to cash crops meant for distant markets.
Right. And it took time for the Sears Roebuck catalog to invent a national mail-order business model that utilized the freight lines.
And it took time for hotels, factories, and entire cities to physically relocate alongside the tracks.
So while all that co-invention was happening, the tracks are just sitting there, underutilized,
Not generating enough revenue to pay back the massive debt required to build them.
which led to massive financial panics. In the 1870s and 1890s, the railroad bubbles burst.
People lost everything.
Major banks failed, investors were wiped out, and the economy was thrown into depression.
Ouch.
But, and this is the critical lesson, the tracks didn't disappear.
Right, the physical steel was still on the ground.
Exactly. The infrastructure remained. And when the economy eventually caught up and the co-invention lag ended, the ROI on those railroads was astronomical.
So the question the market is wrestling with today is, are AI data centers the new steel tracks?
That's the exact parallel.
Are the Magnificent Seven laying down gigawatts of computational infrastructure before the software layer, the cities and factories of the AI world, has actually been built to utilize them?
That is the exact fear keeping investors up at night. The capital expenditure is running years ahead of the actual software applications.
It feels very similar to the dot-com boom.
Funny you say that, because our source points to a fascinating piece of financial journalism to drive this point home.
What was it?
In 1999, right at the absolute peak of the dot-com euphoria, the Wall Street Journal published an article warning investors.
What did it say?
They explicitly stated that the hyper-speculation around internet stocks looked exactly like the hyper-speculation around electricity stocks in the 1880s.
That is incredible foresight for 1999.
It really was.
And we all know what happened next. The dot-com bubble spectacularly burst in 2000. Trillions of dollars of paper wealth simply evaporated.
The NASDAQ collapsed. Pets.com went to zero.
The bubble popped because the infrastructure of the internet, the fiber optic cables, the servers had been overbuilt relative to what a 56K dial-up modem and a basic HTML website could actually deliver in value to a consumer.
Exactly. The expectations got too far ahead of the reality of the co-invention lag.
But look at what happened over the next 20 years.
Right. The internet became the defining infrastructure of global commerce.
It exceeded even the most hallucinatory, optimistic science fiction predictions of 1999.
And those fiber optic cables that were laid during the bubble, the ones sold for pennies on the dollar after the crash.
They became the literal backbone of cloud computing, streaming video, and the mobile revolution.
Both electricity and the internet experienced massive, devastating speculative bubbles that burst. But both technologies fundamentally delivered on their underlying promise over the long term.
Their societal and economic impact made the initial hype look incredibly conservative.
Precisely.
Let's translate this macroeconomic theory into actionable reality for the listener.
Okay.
What does a bubble bursting actually mean for someone building a career right now? Because I think people hear bubble and they assume the technology itself is a complete fraud.
Right, that's a common misconception. A financial bubble bursting does not invalidate the underlying technology.
What is it then?
It is simply a harsh correction of future expectations.
Mm.
A stock price is fundamentally just a mathematical representation of what the market believes a company will earn in the future, discounted back to today.
So if the market suddenly realizes that the AI co-invention lag is going to take 10 years to play out instead of 2 years,
Those future earnings are pushed much further out into the horizon.
the math changes. The discount rate applies harder, expectations shift, investors panic, and the stock prices correct violently.
The bubble bursts.
But the data centers will still be there.
Yes. The open source models will still be there. The underlying capability of the technology will continue to advance.
So for the individual navigating this space, the takeaway is to mentally decouple the financial turbulence of the stock market from the structural reality of the technology.
Exactly. Expect a wild ride.
Expect to see weeks where the hype is deafening, followed by months of deep disillusionment.
Expect to see headlines declaring generative AI is a dead end, and expect to see major tech stocks take a beating.
But beneath that surface-level noise, you have to understand that the long-term trajectory is locked in.
The tracks are being laid. The cognitive factory floor will be redesigned.
Which brings us to the inevitable question. Let's assume the turbulence passes.
Okay.
The co-invention lag ends. The new workflows are built. What actually happens to human labor when the technology clicks into place?
This is the core anxiety for most people.
Because if we drop the analogies and look at the raw capabilities of the models right now, it is intimidating.
Highly intimidating.
If an AI agent can ingest 10,000 pages of case law, synthesize the precedents, and draft a flawless legal brief in 10 minutes, a task that would take a junior lawyer a full 40-hour workweek.
Aren't lawyers effectively obsolete?
Exactly. If the machine does the work of 10 people, don't we have to fire 9 people?
It is a completely logical fear if you view the global economy as a static, finite pie.
Minu.
The assumption is that there is a fixed amount of legal work that needs to be done in the world, and if machines do it faster, human labor is no longer required.
But that framework ignores one of the most powerful forces in economics.
Yes, the elasticity of demand.
Elasticity of demand. I want to spend some real time breaking this down because understanding this concept is the antidote to the doom loop thinking so many people are stuck in.
It really is.
I'll take a swing at explaining it. Elasticity of demand essentially measures how wildly consumer behavior changes when the price of a good or service drops.
Correct.
A great historical example for our technological-minded audience is computing power itself. Think about data storage.
Good example.
Decades ago, storing a gigabyte of data was incredibly expensive. You had to buy physical hard drives, rack space, cooling.
It cost a fortune.
Because it was expensive, our demand for storage was highly inelastic in a way. We only stored the most vital, mission-critical database information. We were frugal.
But then, Moore's law and the advent of cloud computing drove the cost of data storage down to fractions of a penny.
And what did society do when the price plummeted? We didn't just store the same amount of vital data and pocket the financial savings.
No, we exploded our demand.
Exactly. Because storage became effectively free, we started storing high-definition videos of our breakfast.
We created streaming platforms hosting millions of hours of 4K video.
We created social networks built entirely on uploading billions of photos a day.
The drop in price unlocked a massive latent demand for a service we didn't even know we wanted at that scale.
The pie didn't shrink. It grew by orders of magnitude.
That is the perfect illustration of highly elastic demand. Now, apply that exact same mechanism to the knowledge economy.
Okay, let's return to the legal profession.
The total demand for legal services on Earth is not a fixed, finite pie. The only reason we do not consume vastly more legal services today is that it is prohibitively expensive and highly gated.
Most individuals and small businesses simply cannot afford a lawyer.
Right. If a vendor breaches a small contract or a landlord violates a minor lease term, the average person doesn't sue.
Because hiring a lawyer for $500 an hour to fight a $2,000 dispute is completely irrational. They just absorb the loss.
But imagine a world where AI drops the cost of generating high-quality legal work from $500 an hour to 50 cents a minute.
The price of legal intelligence plummets.
And as the price plummets, the latent demand is unlocked. Millions of small businesses suddenly start utilizing legal services for every single contract they sign.
Every day people start enforcing their tenant rights.
The overall volume of legal work required by society expands massively.
So the question is not whether AI will allow one lawyer to do the work of 10, leading to 9 being fired.
The reality is that the demand for legal services might expand 100-fold.
Meaning, we actually need more human lawyers in the system to manage, oversee, and deploy those AI agents.
Exactly. Our source material uses the healthcare industry as the ultimate high-stakes example of this elasticity.
Let's talk about healthcare, because that hits home for everyone.
Healthcare is the perfect proxy because it is a sector defined by scarcity. In many parts of the world, healthcare is incredibly expensive, wait times are long, and the quality of diagnostic care has enormous room for improvement.
And the fear is that if we build an AI that possesses superhuman diagnostic accuracy, an AI that can read an MRI or a pathology slide better than the top human specialist, we will replace the doctors.
Which is an absurd premise when you think about human nature.
Why?
There is no artificial ceiling on human health. We don't reach a certain baseline of health and say, okay, that's enough, we're good.
Well, that's true.
If the cost of world-class diagnostics drops to a fraction of a cent, we do not fire doctors. We expand what is medically possible.
Instead of getting an MRI only when you are showing severe symptoms of illness, perhaps every human being gets a full-body preventative MRI every single month.
We shift from reactive medicine to ultra-personalized preventative medicine.
The demand for medical interpretation, patient care, and treatment planning scales exponentially.
The service becomes vastly more accessible, and the need for human medical professionals to interface with patients and make complex care decisions actually increases.
So for you listening, this is the foundational mindset shift you have to make.
Stop viewing AI as a zero-sum game.
The AI is not coming to eat your slice of the pie. The AI is coming to dramatically expand the size of the bakery.
Beautifully said.
But, and this is the massive pivot point of our entire discussion, even if the sheer volume of jobs increases, the actual nature of the work you do on a daily basis has to fundamentally transform.
Yeah.
Because if the machine is reading the MRI, and the machine is drafting the legal brief, and the machine is writing the Python code, what exactly is the human being doing all day?
This brings us to the absolute core of the source material. If you understand nothing else from this deep dive, understand this framework.
Let's lay it out.
The Economist argues that you must deconstruct the knowledge economy into its two fundamental cognitive tasks.
Everything we do at a desk can be split into 2 buckets.
Yes, prediction and judgment.
Prediction and judgment. Let's pull these apart. Let's start with prediction because that is the domain of the machine.
Right. Despite the science fiction narratives, despite the uncanny feeling you get when a chatbot speaks to you with empathy,
Artificial intelligence is fundamentally just computational statistics.
it is math. Whether you are using an LLM to generate language, a computer vision model to navigate a self-driving car, or a reinforcement learning model to control a robotic arm, The underlying mechanism is statistical prediction.
The system is looking at a massive, multidimensional data set and calculating the most mathematically probable next token, the next pixel, or the next joint movement.
It is predicting the future state based on historical patterns, and it is doing it at a speed and scale that is approaching superhuman levels.
It is an unparalleled prediction engine.
But here is the massive, glaring blind spot.
That's missing.
The thing that AI completely lacks and fundamentally cannot possess is judgment.
Judgment.
AI has zero judgment because AI is a machine. It has no wants. It has no desires. It has no moral compass.
It does not care if a corporation goes bankrupt or achieves a $1 trillion valuation.
It's not care if a patient lives or dies.
Yeah.
It just predicts outcomes based on the data it was trained on.
To avoid those cliche metaphors about genies and lamps, let's think about it mechanically.
Sure.
An AI model is essentially a massive, incredibly powerful V8 engine sitting in a garage. It has immense horsepower. It can generate incredible velocity.
But without a human being to bolt that engine into a chassis, steer the wheel, and press the gas pedal, it is completely inert.
It just sits there burning fuel. Human desire is the steering wheel.
The human must provide the direction. We have to possess the desire to want a specific outcome built in the world.
And once the machine generates a prediction or executes a task, the human must apply judgment.
To evaluate if that outcome is actually beneficial, if it aligns with our ethical values, and if the inherent trade-offs are acceptable.
The Economist in our source material uses a brilliant historical example to make this abstract concept of prediction versus judgment incredibly concrete.
It's arguably the most clarifying analogy in the entire deep dive.
It takes us back to the 1980s, looking at business schools and the accounting profession.
It is a masterful mental model. Imagine walking into a top-tier university business school 40 years ago.
Okay.
The most prestigious, rigorous major you could pursue was accounting. And if you closely examined what those elite accounting students actually did on a daily basis, roughly 80% of their cognitive effort was dedicated to manual arithmetic.
Just adding, subtracting, carrying the one, balancing physical ledger books.
A whole source even points out that professors would assign homework where students were told to turn to a random page in the local physical phone book.
And manually add up every single 7-digit phone number on the page.
Exactly. The entire pedagogical goal was to build the physical and mental muscle memory required to become a flawless human calculator.
Because in the 1980s, generating the math, the prediction of the ledger, was 80% of the value an accountant provided to a business.
But then, almost overnight, the paradigm shattered.
The electronic spreadsheet arrived. VisiCalc, Lotus 123, and eventually Microsoft Excel.
The spreadsheet drops onto the corporate world like a meteor.
And in the context of arithmetic, the spreadsheet is essentially artificial general intelligence.
It is flawlessly, superhumanly perfect at addition and subtraction. It never makes a typo. It never gets fatigued at 2 a.m. And it calculates complex formulas across thousands of cells instantaneously.
If you were a senior accountant in 1985 whose entire professional identity and value proposition were based on being the fastest, most accurate human calculator in the firm,
You would look at a glowing Excel screen and think, it's over. My profession is entirely obsolete. The machine has automated my brain.
the logical conclusion would be mass unemployment for accountants.
But that isn't what happened.
No,
Wow.
there are significantly more accountants, financial analysts, and quantitative strategists working today than there were before the invention of the spreadsheet.
Because the nature of the job shifted instantaneously from prediction to judgment.
The spreadsheet can calculate the numbers with perfect accuracy, but the software has absolutely no idea which numbers actually matter.
Exactly. The spreadsheet does not know what the CEO's strategic risk tolerance is.
It does not know if aggressively utilizing a specific tax loophole violates the company's moral code or jeopardizes its public relations standing.
The human accountant uses judgment to decide which variables actually go into the machine in the first place.
They interpret the superhuman output, they weigh the strategic trade-offs of different financial scenarios, and they advise the business on how to act in the physical world.
The spreadsheet handles the execution. The human handles the strategy.
Which brings us to the core takeaway for you listening right now.
Moving forward in the AI era, your pure technical execution skills are rapidly becoming commodities.
The ability to write syntax-perfect code, the ability to draft a grammatically flawless marketing email, the ability to manually build a complex pivot table.
Those are acts of prediction. The machine will do them instantly.
The most valuable person in any corporate room is no longer the fastest coder or the most articulate writer.
It is the individual who can most effectively evaluate the outputs of a supercomputer.
The source explicitly states that skills will trump jobs. This is a massive paradigm shift.
Let's apply this. Say you are a mid-level marketing manager today.
Okay.
Historically, your career ceiling might have been limited if you weren't a great copywriter or if you struggled with the technical aspects of data analysis.
But tomorrow, the AI agent can write 50 variations of the ad copy and build the data analytics dashboard in 10 seconds.
Right. If you are the person who possesses superior judgment, who understands the deep psychological nuances of targeting a specific demographic,
Who can look at 3 different AI-generated campaign strategies and instinctively know which one aligns with the brand's long-term ethos.
you will dominate that department.
The organizational charts of the future are going to be scrambled. Individuals with high judgment will rapidly rise to leadership positions, regardless of their legacy technical execution skills.
Because they will essentially operate as miniature CEOs managing a vast fleet of AI agents.
I want to take this abstract concept of judgment and ground it in the physical reality of how our daily work is going to change.
That's important.
Because to apply this judgment, the way we structure our businesses has to evolve. Let's connect the story of the electricity factory floor, where they finally tore down the timber columns, to the cognitive factory floor of tomorrow.
Because AI is not just going to speed up our tasks, it is going to completely collapse the modern business process.
This is where we transition from localized productivity gains to massive systemic economic restructuring.
The source provides a masterclass example of this by deconstructing a standard routine 7-minute doctor's visit.
Let's walk through the mechanics of this, because the current state of this workflow is a perfect example of a bloated, inefficient, steam-powered process.
Consider what actually happens during and after a routine medical checkup.
You sit in the room, the doctor asks you a series of questions, checks your vitals, jots down some shorthand notes, and the 7-minute interaction concludes.
But that brief conversation kicks off a massively complex, global, invisible assembly line.
At the end of their shift, that highly trained doctor has to sit at a computer terminal for 2 hours, manually typing up the electronic medical records for every patient they saw.
Which is a massive misallocation of their cognitive skills and a primary driver of physician burnout.
Totally. And then once those records are typed, they are often batched and transmitted overseas.
Frequently to massive processing centers in India, working the overnight shift.
There, Huron medical coders read the doctor's narrative notes and manually translate them into highly specific alphanumeric reimbursement codes, like ICD-10 codes, CPT codes.
They are acting as human translation layers between the medical reality and the financial system.
Those codes are then transmitted back to the hospital's billing department in the U.S.,
The billing department formats them into a claim and submits them to a medical clearinghouse.
which scrubs them for errors before finally routing them to the ultimate payer, like Medicare or a private insurance company.
And then the insurance company's adjudication engine reviews the claim against the patient-specific policy.
And eventually, weeks or months later, a financial transaction is authorized and a payment is issued to the hospital.
It is a staggering, multi-step, multi-continent logistical supply chain, employing hundreds of people.
All generated by a 7-minute conversation about a sore throat.
Now, observe how the healthcare industry is currently attempting to apply artificial intelligence to this problem.
They're building AI wrappers, right?
Yes. Today, startups are selling AI scribe tools that listen to the audio of the 7-minute visit and automatically draft the doctor's clinical notes in 3 minutes instead of 2 hours.
And other companies are building AI tools for the offshore coders to help them assign the ICD-10 codes in 30 seconds instead of 5 minutes.
Which sounds great on the surface. Things are moving faster.
It is faster, yeah. But structurally, it is just putting an electric motor on the old steam shaft.
Exactly. It is taking the exact same inefficient, bloated, multi-step workflow and just applying AI wrappers to slightly accelerate the individual silos.
So what's the real transformation look like?
The true co-invention of the cognitive factory floor happens when that entire middle section of the assembly line is recognized as unnecessary and completely collapses.
Walk us through the mechanics of that collapse. How does the middle evaporate?
In a fully realized AI native architecture, The raw audio data generated during that 7-minute interaction does not need to be translated into human-readable notes, sent to India, coded, sent to billing, and sent to a clearinghouse.
What happens instead?
The AI ambiently listening to the conversation acts as an intelligent routing layer.
The moment the doctor confirms the diagnosis verbally,
The AI securely connects directly to the insurance company's API endpoints.
it instantly cross-references the patient's medical history, validates the required clinical evidence, maps it to the precise billing codes.
And auto-adjudicates the claim with the payer's system in milliseconds.
The financial transaction is executed, and the hospital is paid the exact minute the patient walks out the clinic door.
The entire administrative middle layer, the dictation, the offshore coding, the hospital billing department, the clearinghouse, is simply bypassed.
The workflow is flattened.
Completely flat.
But this forces a very uncomfortable conversation about the reality of white-collar work.
It does.
If the entire middle of the assembly line evaporates, a massive portion of the global workforce currently resides in that middle layer.
Let's bring this back to the lawyer.
Right. If the act of researching the precedents and drafting the 50-page legal brief, the execution middle layer, is completely automated by an AI agent, what is the human lawyer actually getting paid to do?
The value of human labor, and therefore the competition, moves entirely upstream.
Upstream.
If every law firm on Earth has access to an AI agent that can draft a syntactically perfect, exhaustively researched brief in seconds, the sheer act of writing is no longer a competitive advantage.
It is commoditized.
The economic premium shifts entirely to the upstream thinking. It shifts to high-level legal strategy, to assessing the nuanced liability of a complex merger.
To predicting the emotional and psychological reactions of a jury, to wargaming multi-year litigation scenarios.
The human shifts from being an executor to being an auditor and a strategist.
You are not manually typing the document. You are applying intense cognitive scrutiny to audit the AI's document.
Ensuring it perfectly maps to the strategic reality of your client's unique situation.
This fundamentally debunks one of the most pervasive, pessimistic myths regarding the AI transition.
You mean the Wall-E future?
Yeah, the Pixar movie. The dystopian vision where humans are confined to floating hover chairs, drinking massive sodas, staring at screens.
While robots handle every single aspect of survival and logistics.
We lose the physical and cognitive ability to even fend for ourselves. We just atrophy.
Yes, the assumption that offloading execution to machines will make humans cognitively lazy.
But the economic reality points in the exact opposite direction.
Because the rote, repetitive execution is automated, human jobs will actually be composed entirely of high-level abstract thinking, deep ethical evaluation, and complex multivariable trade-off analysis.
The day-to-day reality of work actually becomes significantly more cognitively demanding.
Humans will be required to bring more cognitive heat, more intense judgment to the table, not less.
I see where you're going with this, but it raises a massive structural red flag regarding how we actually train people.
The pipeline problem.
Exactly. If the entire cognitive factory floor is redesigned so that all the entry-level execution jobs are handled by AI.
The junior associate drafting the simple legal memos, the junior copywriter writing the basic social media posts, the junior developer writing the boilerplate code.
How does a young person ever build the foundational experience required to eventually possess high-level judgment?
They don't just wake up at age 30 with brilliant strategic insight. They earn it by doing the grunt work.
If the grunt work is gone, the pipeline of human talent is broken.
You have identified the most critical crisis facing the modern labor market, the crisis of the junior worker.
And this is not a theoretical future problem, is it?
No, it is already manifesting in the macroeconomic data. The source references a highly impactful recent study out of Stanford University, tellingly titled Canary in the Coal Mine.
A title that doesn't exactly inspire optimism.
Not at all. The researchers analyzed comprehensive employment data, focusing specifically on young workers, ages 22 to 25.
People who are attempting to enter industries highly exposed to generative AI.
We are talking about fields like software engineering, digital marketing, finance, and copywriting.
What did the data show?
The data revealed a stark 6% decline in overall employment for that specific age cohort.
Wow.
Furthermore, corroborating studies have shown up to a 22% decline in hiring for brand new college graduates entering these knowledge work fields.
22% is a catastrophic drop for an entire generation entering the workforce.
It strongly implies that the canary is already dead.
Corporate executives are clearly looking at their org charts and saying, why would I pay a 22-year-old junior copywriter a salary with benefits to write mediocre first drafts when an enterprise LLM can generate 50 variations of superior copy instantly for fractions of a penny?
That is the immediate visceral conclusion that the media and the public jump to.
But is there a catch?
Yes. Our expert, analyzing this through the lens of deep economics, points out a bizarre anomaly in the data that vastly complicates that simple narrative of doom.
What's the anomaly?
Yes, employment numbers for these young workers dropped significantly at the major firms measured by the study, but their wages did not fall.
Wait, I'm going to push back on that because that violates the most basic rule of supply and demand.
Exactly.
If the demand for junior knowledge workers is truly crashing that hard, the market should be flooded with desperate, unemployed college grads.
And when supply outstrips demand, the price of that labor wages should plummet as grads compete to undercut each other just to get a foot in the door.
If wages aren't falling, something else is happening.
Precisely. When demand evaporates, prices fall. The fact that junior wages remain stable suggests the Stanford data might be missing a massive, invisible migration.
Where are they going?
Well, these studies primarily measure employment by analyzing payroll data from established, mid to large-size corporate firms.
Okay.
The expert speculates that these 22-year-old software developers and marketers are not sitting at home unemployed and defeated.
They're fleeing the traditional corporate ladder entirely.
They're moving to agile, shadow market startups, or they're leveraging the massive leverage of AI tools to start their own micro-agencies.
Entities which simply are not captured by traditional macroeconomic data sets.
That makes perfect sense.
If you are a brilliant 22-year-old coder and a massive legacy tech company refuses to hire you because they automated their junior dev tier, you don't give up.
You grab the open source AI coding agents yourself, you team up with two friends, and you build a highly complex software product in a garage.
A product that would have required a 50-person engineering team 5 years ago.
You bypass the gatekeepers completely.
It is a massive democratization of entrepreneurial capability.
But even with that optimistic caveat regarding the startup migration, your foundational question remains the central challenge for society.
If an AI agent has ingested the entirety of the internet, read every textbook ever published, memorized every legal precedent, and parsed every medical journal,
How can a human being, fresh out of a university, possibly compete on the basis of knowledge?
they can't. If I spend 4 years memorizing a textbook, I am still effectively a million times dumber and slower than the foundational model sitting on my phone.
Which means the entire paradigm of human education must shift epochs.
The source cites the brilliant Turing Prize-winning computer scientist Rich Sutton on this exact point.
Yes, Sutton argues that humanity is rapidly transitioning from an era of data into an era of experience.
Attempting to build a career by accumulating and retaining data is a losing battle.
The machine has won the era of data. You can no longer learn simply by reading. You have to learn by doing.
But what does doing actually mean in a cognitive context? Because the entire structure of the modern university system is predicated on reading a textbook, synthesizing the data, and writing an essay to prove you retained it.
Doing, in the era of experience, means placing yourself in environments where you are forced to make high-stakes decisions under conditions of deep uncertainty.
It means you must personally own the outcome of those decisions.
And crucially, you must feel the actual visceral pain of making a bad choice.
Feeling the pain. That is an incredibly stark way to phrase educational development.
But it is the biological reality of how human judgment is formed.
Give me an example.
Consider how a young child learns that a hot stove is dangerous. You can sit them down and read them a textbook on the physics of thermodynamics.
You can explain the transfer of heat energy.
They might memorize the data, but they don't truly understand the danger until they reach out, touch the glowing coil, and feel the physical burn.
That immediate visceral feedback loop, the decision, the consequence, the pain, or the reward, is the only mechanism by which the human brain physically wires the neural pathways of judgment.
You learn to weigh complex, competing trade-offs only because you have survived the consequences of getting those trade-offs wrong in the past.
Which serves as a devastating fundamental critique of the current higher education system.
We are charging young people hundreds of thousands of dollars to sit in safe, sterile lecture halls, memorizing data to compete with supercomputers.
It is entirely misaligned with the future economy.
The expert explicitly argues that universities require a ground-up philosophical reorganization.
They must shift away from being repositories of facts and transition into operating as complex, simulated environments.
We need educational models where students are thrown into chaotic multivariable projects, forced to make strategic choices, and forced to face the simulated consequences of failure.
So for the 22-year-old listener who is feeling the anxiety of that shrinking corporate hiring pipeline, the actionable advice is clear.
Do not try to solve your career anxiety by retreating into another master's degree just to read more books and pad your resume with data.
Go build something in the real world. Start a side hustle where you have to manage a real profit and loss statement.
Volunteer to organize a massive logistical event for a local charity where failure has public consequences.
Willingly put yourself in arenas where you have to make choices, where you are highly likely to fail, and where you have to publicly own that failure.
That is not a setback. That is the rapid accumulation of judgment.
It is the only way to build your own apprenticeship of experience.
You must actively seek out the friction that builds the human mode.
We have dedicated a massive amount of time to analyzing the cognitive side of this revolution, the knowledge workers, the lawyers, the marketers, the doctors.
Yes.
But I want to shift our focus to the final, most terrifying, and arguably most exciting frontier of artificial intelligence.
Because this is where the conversation escapes the spreadsheet and enters the physical world.
Let's talk about AGI and the deployment of advanced robotics.
This is the domain where the extreme hype of Silicon Valley and the grounded reality of physics crash into each other with spectacular force.
For you listening, AGI stands for Artificial General Intelligence. It is the ultimate holy grail of the computer science field.
The prevailing working definition of AGI is a synthetic system that equals or surpasses the cognitive capabilities of a human being across absolutely every economically valuable task.
And the benchmarks the industry is using to measure our progress toward AGI are becoming staggeringly complex.
The source mentions a specific evaluation protocol called humanity's last exam.
Right. Recently, when Elon Musk's XAI released their advanced Grok model, they explicitly benchmarked its performance against this test.
Humanity's last exam is not a standardized college entrance exam. It is a massive, incredibly dense battery of PhD-level, expert-crafted technical questions.
Spanning organic chemistry, quantum physics, molecular biology, obscure Latin translations, and advanced theoretical mathematics.
The premise is that any AI system capable of passing this exam wouldn't just be smarter than your average high school graduate. It would effectively possess more synthesized knowledge and problem-solving capability than a Nobel laureate across multiple, completely unrelated scientific disciplines.
A machine that holds the combined synthesized genius of every Nobel Prize winner in human history, accessible via an API call.
That is a concept that is simultaneously awe-inspiring and deeply terrifying.
It is the defining technological achievement of our species.
But The Economist in our source material pushes back on the economic utility of this specific vision of AGI in a profoundly pragmatic way.
How so?
He highlights a well-known essay written by Dario Amodei, the CEO of Anthropic, which is currently one of the leading frontier AI labs.
In this essay, the CEO articulates his vision of AGI as essentially creating a country of geniuses in a data center.
A sovereign nation of invisible, hyper-intelligent entities living inside server racks, working 24/7.
Exactly. But The Economist asks a beautifully simple, grounding question. Okay, let us assume we achieve that exactly as described. We have a country of geniuses in a box today. What does that actually do to the physical economy?
Consider an average, mid-sized business operating in the real world. Think of a regional retail chain, a commercial bakery, a construction firm, or a manufacturing plant.
How many Nobel Prize-winning geniuses do those companies currently employ?
0. They couldn't afford one, and they wouldn't know what to do with one if they had them.
Precisely. And how many theoretical physicists do they need to employ to effectively bake a loaf of bread, pour a concrete foundation, or manage inventory in a warehouse?
Still 0.
Right. The vast majority of the global GDP does not require the cognitive input of a Nobel laureate.
What the physical economy desperately needs is physical execution.
The Anthropic CEO's country of geniuses might be able to compose a breathtaking symphony, solve a previously intractable equation in quantum mechanics, and draft a flawless international trade agreement.
But it cannot physically pick up a glass of water and hand it to you.
Because it is entirely trapped in the digital realm, it has no physical embodiment. It is a brain without hands.
And this highlights the massive, glaring bottleneck in the current AI revolution. We're experiencing what computer scientists call Moravec's paradox.
Moravec's paradox.
High-level cognitive reasoning, which we thought was the pinnacle of human intelligence, turns out to be computationally relatively easy for AI.
But low-level sensorimotor skills, the physical acts of walking upstairs, grasping a fragile egg without crushing it, or navigating a cluttered room.
Those are insanely difficult to program. The cognitive intelligence of AI is advancing at light speed, but robotics, the physical instantiation of that intelligence, is lagging decades behind.
But that bottleneck is finally starting to crack, isn't it? The source goes deep into the recent advancements in humanoid robots.
We're seeing companies like Sanctuary AI up in Canada, and obviously the massive push from Tesla with the Optimus humanoid program.
Yes, and the reason we are simultaneously seeing rapid progress in robotics is fascinating because the foundational architecture is circling right back to the core concept we discussed earlier. AI is just computational statistics.
It is just predicting the next token.
I need you to break down the mechanics of this. How does the architecture of a language model, a system designed to predict text on a screen, translate to the physical kinematics of a 100-pound metal robot walking across a factory floor?
It requires a shift in how we view the data. When you interact with ChatGPT, the model is generating a sentence by analyzing the vast context of previous words and predicting the most mathematically probable next word or token in the sequence.
To the AI, the entirety of human language is just a highly restricted, very small library of arbitrary symbols, 26 letters, a handful of punctuation marks, some spaces.
The model simply resequences those few foundational symbols in infinite complex combinations to write a sonnet or generate Python code.
It is just arranging the alphabet based on probability.
Exactly. The cutting-edge robotics companies have realized they can use the exact same autoregressive architecture. But instead of feeding the model a library of text tokens, they train the AI on a small library of fundamental physical verbs.
Verbs. Physical action states.
Precisely. They train the robot's neural network on a limited vocabulary of basic movements. Reach, grasp, pull, push, lift, step, rotate.
Just like the letters of the alphabet.
Once the model deeply understands the physics of those basic verbs, the AI's task is no longer to predict the next word in a sentence. Its task is simply to predict the correct sequence of physical verbs required to complete a complex real-world goal.
This completely changes my understanding of robotics. So if the overarching goal is make a cup of coffee, the software engineers are no longer rigidly writing millions of lines of conditional if-then code. If cup is present, move arm 12 degrees, open actuator 3 centimeters.
Instead, the AI looks at the visual data of the kitchen and simply predicts the token sequence. Verb 1, walk to counter. Verb 2, reach arm. Verb 3, grasp handle. Verb 4, lift.
It is literally just physical autocomplete.
Physical autocomplete. That is the perfect conceptual framing. And because it operates on this generalized predictive model rather than rigid, brittle, hard-coded rules, the expert makes a massive prediction.
He argues that we are rapidly approaching a ChatGPT moment for humanoid robots.
What exactly does a ChatGPT moment look like when applied to a bipedal machine in the physical world?
Think back to the cultural shockwave of December 2022, when ChatGPT first became available to the public. The magic was not that it could accurately answer one specific pre-programmed question.
The magic was its profound generality.
You could throw absolutely any prompt at it, write a melancholic poem about a toaster, or explain string theory in the voice of a 1920s gangster, or debug this block of C++ code, and the model could dynamically generate a highly competent attempt without having been explicitly pre-programmed for that exact narrow scenario.
It broke out of the rigid drop-down menus and specific button clicks we have been trained to expect from software. It was fluid.
Exactly. Right now, when you see a viral video on social media of a robot doing a backflip or flawlessly folding a t-shirt, it is almost always performing a highly narrow, heavily rehearsed task in a tightly controlled laboratory environment.
But the paradigm will shift. The penny will drop for the general public when a humanoid robot is placed in a random, chaotic, unstructured room it has never seen before, and a human verbally commands it to do a sequence of novel tasks.
Hey, clean up the dog toys on the floor, empty the bottom rack of the dishwasher, and go get me an apple from the fridge.
And the robot simply dynamically sequences the verbs, navigates the clutter, and executes the physical labor.
That is the moment the world changes forever. Let's put a hard timeline on this. Based on the economic and technological trends, when does the expert predict we actually cross that threshold?
He offers a highly specific phased prediction. He believes we are roughly 10 years away from the wide-scale deployment of a factory-grade general robot.
This refers to a humanoid capable of dynamically executing a wide range of physical tasks, but constrained to a somewhat controlled, structured environment.
Think of a massive logistics warehouse, where the lighting is consistent, the floors are perfectly flat, and the pathways are relatively predictable.
10 years to automate the warehouse and the assembly line. Okay. What about the ultimate goal? The robot out in the wild in the chaos of the human world.
He predicts we are 20 years away from a generally capable bipedal robot that can reliably navigate fully uncontrolled adversarial environments.
Walking down a bustling, icy city street, dynamically dodging unpredictable pedestrians, navigating the chaotic, constantly changing layout of a family living room to fold laundry without stepping on the cat.
20 years.
Wow.
So within the span of 2 decades, we could realistically share the planet with millions of humanoid machines capable of performing almost any manual physical labor a human can do.
Powered by a cognitive AI brain that processes information better than a Nobel laureate.
That is the technological trajectory we are currently accelerating along.
Which brings us to the final and undoubtedly most existential segment of our deep dive today.
We have to confront the ultimate endpoint of this economic shift.
If we extrapolate these trends out, if autonomous machines handle the entirety of physical labor, mining the resources, building the infrastructure, harvesting the food, and folding the laundry.
And if advanced AI agents handle all the cognitive heavy lifting, diagnosing the diseases, drafting the legislation, optimizing the global supply chains,
What exactly is left for the human race to actually do?
you are asking the defining philosophical and economic question of our century. You are asking about the transition into the post-work world.
Post-work. It sounds like a utopian science fiction concept where nobody ever has to set an alarm clock again.
But if I'm being honest, it also sounds terrifyingly devoid of meaning and purpose. How does an economist even begin to model a society where labor is no longer the central pillar of human existence?
The source approaches this by sharing a remarkable paradigm-shifting perspective from a prominent venture capitalist at Bloomberg Beta.
This VC was hosting a summit on the future of work, addressing all these existential anxieties. And he argued that if you view society through a wide enough historical lens, we are already living in a post-work world.
I'm going to stop you right there. Tell that to the millions of people commuting 2 hours a day to work multiple jobs just to pay their mortgage and afford groceries.
Telling the modern working class they live in a post-work utopia is going to go over like a lead balloon.
The VC's point relies on historical relativity. Consider the definition of work a century ago.
If you could somehow transport an average working-class factory worker from 1915 into the present day.
Someone whose entire existence consisted of 14 hours a day of brutal, life-shortening, back-breaking physical labor deep in a coal mine or inhaling cotton dust in a textile mill just to earn enough calories to survive the week.
And you showed them what the vast majority of the modern knowledge economy considers work.
Which is us sitting in ergonomically designed, comfortable chairs in a perfectly climate-controlled room, drinking filtered water, talking into microphones, and moving abstract information around on glowing screens.
Exactly. That 1915 factory worker would look at our lives and emphatically state, "You people do not work. You are soft aristocrats living in an unimaginable post-work utopia."
The definition of what constitutes labor is entirely relative to the technological baseline of the era.
Humanity has already successfully offloaded immense, unimaginable amounts of physical toil and suffering to mechanical machines since the dawn of the Industrial Revolution.
Generative AI is simply the next logical continuation of that long historical arc, but instead of offloading the physical strain of our muscles, we're offloading the rote, repetitive strain of our cognition.
That is a phenomenal reframing of the narrative. We already survived the end of manual labor being the dominant, necessary form of human existence.
The agricultural revolution didn't end human purpose. It just freed us up to invent the modern world. We adapted and we found new, vastly more complex things to do.
Precisely. The end of one form of labor is simply the beginning of another. And the expert brings up an absolutely brilliant, almost poetic analogy to explain how human psychology will adapt to a true AI-driven post-work future.
He uses the social dynamics of the British historical drama series, Downton Abbey.
Downton Abbey, the television show about the ultra-wealthy British aristocrats living in a massive country estate before World War I.
Yes. If you analyze the structural dynamics of that show, you essentially have a perfect microcosm of the future economy.
You have the massive staff of servants living downstairs. They perform all the traditional, recognizable work, the grueling cooking, the endless cleaning, the intense logistical management of the massive estate.
And then you have Lord Grantham and his aristocratic family living upstairs. By the standards of the era, the family upstairs performs absolutely zero traditional work.
They are completely and utterly unburdened by the requirements of physical survival.
Right. Their biggest daily physical challenge is changing outfits for an 8-course dinner or taking a leisurely stroll through the rose garden.
But, and this is the vital psychological insight, if you watch the show, are the aristocrats upstairs just sitting around in a catatonic state, staring at the walls, doing nothing?
Are their lives peaceful, empty, and devoid of purpose?
Absolutely not. They are a nervous wreck most of the time. They are constantly stressed, endlessly scheming, gossiping, forming alliances, trying to manipulate social standing, trying to strategically marry their children into the right rival families.
They are intensely busy.
Exactly. They are fiercely, relentlessly competing, because this is the fundamental truth of human nature. As long as there is any form of scarcity in the world, human beings will compete for it.
In a future where advanced AI and robotics can produce virtually infinite food, build infinite shelter, and manufacture infinite material goods, we will no longer need to compete for basic biological survival.
Scarcity of the physical necessities will end, but humans will immediately pivot and begin competing for the things that remain inherently scarce: social status, political power, human affection, cultural influence, and the prestige of charitable recognition.
I hear the analogy, and it is fascinating from a sociological perspective, but I am going to push back hard on this because it feels dangerously detached from the immediate, brutal reality of the transition period.
It's easy to say we'll all be like Lord Grantham competing for status in 50 years when the robots do everything.
But what about the next 10 years? If my job as a mid-level accountant or a junior copywriter gets automated tomorrow, I don't get to move upstairs and worry about my social status.
I still have to pay rent to a landlord who demands US dollars, not cultural influence. I still have to buy groceries in an economy that hasn't reached post-scarcity yet.
How does the average person survive the gap between the evaporation of their cognitive job and the arrival of this utopian abundance?
That is the most vital, urgent critique of this entire economic model, and the source does not dismiss it. The transition period, the gap between the automation of current jobs and the realization of extreme abundance, is where the deepest societal friction will occur.
The expert acknowledges that the economic mechanisms of the transition are messy.
If wages in certain sectors fall before the cost of living drops, we face a profound crisis. This is exactly why the concept of judgment becomes your personal financial lifeline right now.
You cannot wait for universal basic income or a societal restructuring. You have to adapt your personal human capital today.
You must pivot out of the execution roles that are easily automated and aggressively position yourself in the upstream roles of strategy, auditing, and human connection, because those are the roles that will command a premium during the messy, chaotic transition phase.
So even if the grand long-term endpoint is a society where nobody is paid an hourly wage to flip a burger or write a block of code, we will always be working relentlessly toward our own human objectives.
We will be fighting to build communities, creating deeply human art to impress one another, and striving to shape the direction of our culture.
Human desire is bottomless. The machines will never run out of tasks to perform because the human race will never ever run out of things that it wants.
Which brings us full circle right back to the central unifying theme of this entire deep dive.
If human desire is the sole engine driving the AI economy, because the supercomputers, remember, possess absolutely zero wants of their own, then the most valuable protective skill you can possibly cultivate in the next decade is not learning a new programming language.
It is not mastering a specific AI prompt engineering trick. It is not even traditional corporate management.
It is figuring out precisely what you truly want the future to look like. It is the cultivation of deep, rigorous judgment.
It is the ultimate human moat, the uniquely biological ability to evaluate complex moral and strategic trade-offs and chart a deliberate course forward.
You know, we started this deep dive talking about the co-invention lag and the anxiety of the unknown. Building a career used to be like building a house with a very clear, pre-drawn blueprint.
You went to the right school, you learned the specific technical execution steps, you followed the path, and you got the expected result.
That era is over. The blueprint has been burned. The map of the knowledge economy has been completely rewritten.
Moving forward, your ability to deeply desire a specific outcome, to articulate it clearly, to weigh the nuanced ethical and strategic trade-offs, and to demand that vision from the universe or from a fleet of supercomputers is your only true job security.
So as you end this deep dive and go back to your desk or your commute or your family, stop worrying about whether the machine is faster than you. Ask yourself, what is it that you actually want to build tomorrow?